Hello students, today let us see the concepts related to ellipse. They are properties of tangents of an ellipse. Properties of tangents of ellipse. See this one. This is the property. The product of perpendiculars drawn from foci to any tangent of ellipse is constant. That constant is equal to square of its semi-minor axis. You take any ellipse. It has two foci, S and S dash say. Draw the perpendiculars from those foci to any tangent. So you get two perpendiculars from foci to any tangent. Then find out their product of their lengths. That is always equal to what? Square of its semi-minor axis. If your ellipse is x square by a square plus y square by b square is equal to 1, what is semi-minor axis length? 2b. Its half is b. So b square. That should be going to b square. So the product of perpendiculars drawn from foci to any tangent of ellipse is constant, and that constant is equal to b square. You have to show that. Okay. This is your ellipse. X square by a square plus y square by b square is equals to 1. F and f dash are the feet of perpendiculars drawn from foci s comma s dash respectively. What are f and f dash? These are the feet of perpendiculars drawn from foci to s and s dash respectively, say. So what is your claim? Your claim becomes sf into s dash f dash is equals to b square. What is sf? Perpendicular drawn from focus s to tangent. What is s dash f dash? Another perpendicular drawn from s dash to the same tangent. Okay. This is your x-axis, y-axis. It is the given ellipse. What is that? X square by a square plus y square by b square equal to 1. A greater than b, say. This is focus s dash. This is the another focus s. Now consider any tangent as shown in the figure. Now this is the point of contact of the tangent, right? Therefore this is at P, say. Now draw perpendicular from s dash to the tangent, that is s dash f dash. Draw another perpendicular drawn from s to the same tangent as shown in the figure, that is sf. So what you have to prove? You have to prove that s dash f dash into sf is equals to constant, that is equal to b square. That is, you are going to find out b square. We have to prove that product of perpendiculars drawn from foci to the any tangent is b square. So what we have? Foci s r and s dash are ae comma 0 and minus ae comma 0. Consider any tangent of the ellipse. What is the ellipse equation? X square by a square plus y square by b square equal to 1. For any ellipse, the equation of any tangent to that one is what? Y is equal to mx plus r minus root of a square m square plus b square. So I am taking y is equal to mx plus root of a square m square plus b square. This is any general tangent to the ellipse in the slope form. What is m here? Slope of the tangent. Y is equal to mx plus root of a square m square plus b square. So what you have to find? We have to find out the perpendicular distances from s and s dash to this tangent. Therefore, what is SF? Perpendicular distance from S to the tangent. What is perpendicular distance formula? Modulus of ax1 plus by1 plus c by root of a square plus b square. So by applying that formula to this one, what we get? Modulus of aem plus root of a square m square plus b square by root of 1 plus m square. Here a is m, b is equal to minus 1. C is root of a square m square plus b square. This is the one perpendicular distance. Similarly, we can find the another perpendicular distance s dash f dash is equals to modulus of minus AEM plus root of a square m square plus b square by root of 1 plus m square. This is the another perpendicular distance. What you have to do? Product. Now find their product. SF into S dash F dash is equals to, numerator is of the form A plus B into A minus B. What is that? A square minus B square. Under square root should be cancelled out. That is A square M square plus B square minus A square E square M square whole divided by root of 1 plus M square into root of 1 plus M square. That is nothing but 1 plus M square. So modulus of A square M square plus B square minus A square E square M square whole divided by 1 plus M square. Okay. So that is nothing but A square M square into 1 minus E square. I am taking common A square M square from first and last term plus B square by 1 plus M square. So on simplifying this one, B square M square plus B square whole divided by 1 plus M square, because A square into 1 minus E square is nothing but B square. Take again B square common. We get B square into 1 plus M square whole divided by 1 plus M square. So 1 plus M square, 1 plus M square gets cancelled. We obtain B square. This is constant, which is equal to the square of the semi-minor axis. Therefore, the product of perpendiculars drawn from foci to any tangent of the ellipse is always constant, that is equal to B square. So let us see some problem. Now let us see the problem. An ellipse with major and minor axis of lengths 2a and 2b. Major axis length is 2a, minor axis length is 2b, respectively, touches the coordinate axis in the first quadrant. Its foci are given to you, that is x1, y1 and x2, y2. What you have to find out? You have to find out the value x1, x2 and the value y1, y2. One ellipse is there. Its major axis length is 2a and its minor axis length is 2b. And the entire ellipse is in the first quadrant. Its foci are given to you. One is x1, y1 and other one is x2, y2. Then they are asking the values of x1 into x2 and y1 and 2, y2 respectively. For this, what you have to do? Consider the coordinate axis as shown in the figure. This is my ellipse. Length of the major axis is 2a, length of the minor axis is 2b, and the ellipse touches both the coordinate axis in the first quadrant as shown in the figure. This is the axis of the ellipse. These are foci. One foci is x1, y1 and other focus is x2, y2. So the coordinates of the foci are x1, y1 and x2, y2 are given to you. So this is the perpendicular distance from point x1, y1 to the y-axis. This is point x1, y1. This is my first focus. We draw the perpendicular from the point to the y-axis. What is its length immediately? The distance from here to here is x1. So its distance is x1. Similarly, you draw the perpendicular from here to here. That gives what? x2. What are these two distances? These are the perpendicular distances from focus to tangent. Perpendicular distances from this focus as well as this focus to this tangent. Is it y-axis tangent or not? This is the tangent to the ellipse. So similarly, this is the distance x2. So x1 into x2 is nothing but what? The product of perpendiculars drawn from foci to any tangent. Here the tangent is y-axis. By above result, what is that? It is equals to b square for a greater than b. It is equal to a square for a less than b. So for our sake of convenience, we take a greater than b. Then immediately its value is what? B square. Similarly, the perpendicular distance from point x1, y1 to x-axis is what? This is the perpendicular distance. From here to here is y1. Similarly, you can find the perpendicular distance from here to here. That will also gives y2. This is the distance y2. So these are what? Perpendiculars drawn from both the foci to the tangent. Is it tangent or not? X-axis is also tangent. So this is the perpendicular distance from focus to the tangent. This is the perpendicular distance from the another focus to the same tangent. Therefore their product is what? By previous concept, b square. Product of the lengths from focus to any tangent gives b square. Therefore, the product of perpendiculars from foci to any tangent of ellipse is b square. Hence, we get x1 into x2 is equals to y1 into y2 is equal to b square. So, it is a simple concept applied to this problem. Understand? Let us see the another concept. Director circle. The locus of point of perpendicular tangents of an ellipse is called director circle. This is the another concept related to the properties of tangents. Locus of point of intersection of perpendicular tangents of the ellipse is called director circle. Locus of point of intersection of perpendicular tangents of the ellipse is called director circle. You take the pair of tangents, they intersect at some point. You collect all such type of points, you get some circle. That circle is director circle. How to derive this equation? Let us see. This is the x-axis. This is my y-axis. Consider equation of ellipse in the standard form. X square by a square plus y square by b square is equals to 1. This is one of tangent. This is the another tangent. So it is a pair of tangents. They intersect at 90 degrees. This is the angle is 90 degrees. So this point lies on what? My required locus. If you find the locus, you get some curve. That curve is your director circle. So this is the point of intersection. We have to find out the locus of this point P. So you get the locus is as shown in the figure. This is the circle. It is called director circle. So the locus of point of intersection of perpendicular tangents to an ellipse is called director circle. How to prove this one? How to find the director circle equation? Take any general tangent. Let us see the proof. Let Px1 comma y1 be the point of intersection of perpendicular tangents. Px1 y1 is what? Point of intersection of the perpendicular tangents of the ellipse x square by a square plus y square by b square is equals to 1. Consider equation of any tangent of the ellipse in the slope form. What is that? Y is equal to mx plus root of a square m square plus b square. If it is my required tangent, then that must and should be passing through x1 comma y1. To get the required result, you have to substitute the point x1 y1 in my tangent. Y is equals to mx plus root of a square m square plus b square. So, if it is passing through the point P, we get y1 is equal to mx1 plus root of a square m square plus b square. Take mx1 to the left side. We get y1 minus mx1 is equal to root of a square m square plus b square. So, on squaring, we get y1 minus mx1 whole square is equal to a square m square plus b square. Now on simplifying, y1 square plus m square x1 square minus 2m x1 y1 is equals to a square m square plus b square. Now we convert into the quadratic equation in m. X1 square minus a square into m square minus 2m times of x1 y1 plus y1 square minus b square equal to 0. It is quadratic equation in m. It has two roots. Say m1, m2. What are the roots? These are the slopes of tangents drawn from Px1 comma y1 to your ellipse. But your tangents are perpendicular to each other. Therefore, their product of slopes must and should be equal to minus 1. Understand? That is, it is a quadratic equation in m. So, it has two roots m1, m2. Their product of slopes must and should be equal to minus 1. This is m1, m2, that is equals to minus 1. So, product of slopes is what? y1 square minus b square by x1 square minus a square, that is equals to minus 1. On cross multiplying and simplify, we get x1 square plus y1 square is equals to a square plus b square. This is the condition for all x1 comma y1 taken on your locus. Therefore, locus of x1 comma y1 is nothing but x square plus y square is equals to a square plus b square. So, you take any general tangent. First of all, substitute the point where P is the point of intersection of perpendicular tangents. You get some condition on x1 comma y1 and squaring on both sides, you get y1 minus mx1 whole square equal to a square m square plus b square, and convert into the quadratic equation in m. It represents the quadratic in m having two slopes m1 comma m2. These are the roots of this equation. Since the tangents are perpendicular, equate their product of slopes to -1. On that condition, we obtain x1 square plus y1 square equal to a square plus b square. Clearly, we can write the locus of x1 y1 as x square plus y square is equals to a square plus b square. Okay, this is the proof related to the director circle. So simply we can remember that the locus of point of intersection of perpendicular tangents, pairs of perpendicular tangents, always gives a circle. That circle is called director circle. In your parabola, locus of point of intersection of pair of perpendicular tangents is what? Directrix. Here, director circle. So, on the basis of this concept, let us see the problem. An ellipse slides along the coordinate axis. One ellipse is there. It is sliding along the coordinate axis. If the foci of the ellipse are 1, 1 and 3, 3 are given to you, then the area of the director circle of the ellipse is what? The area of the director circle is what? What is area of circle? Pi r square. Once if you know the radius of the circle, your job is over. An ellipse sliding along the coordinate axis. One ellipse is there. It slides along the coordinate axis. Its foci are given to you. 1, 1 is one focus. 3, 3 is the another focus. Let us see. This is my x-axis, y-axis. Its point of intersection is what? Origin. Now, this is the ellipse. Say, it touches both the coordinate axis as shown in the figure. This is the axis of the ellipse having foci at s dash and s. They are namely 1, 1 and 3, 3 say respectively. This is the ellipse. What you have to find out? You have to find out the area of the director circle. So, my question is it tangent to the ellipse or not? Yes. This is also another tangent of the ellipse. The two tangents makes an angle 90 degrees at origin. So, is it the point lies on the director circle or not? This is the point on the director circle because locus of point of intersection of perpendicular tangents of the ellipse is what? Director circle. So, origin is one of the point on the director circle. Again, moreover, director circle is a concentric circle with the center of the ellipse. With the center of the ellipse. That means center of the ellipse and center of the director circle are same. Can you find the center of the ellipse or not? This is nothing but the midpoint of SS dash. You know S and S dash. Clearly you can find the midpoint. That is 1 plus 3 by 2, 1 plus 3 by 2. You get the 1 plus 3 is nothing but 4 by 2 is 2, 2. This is 2, 2 is the center of the ellipse. Once if you know the center of the ellipse, you can easily write the center of the director circle. That is same as 2, 2. You know the center of the director circle. You know the point on the director circle. Can you find the radius of the director circle or not? Yes, we get the radius. After getting the radius, we can write easily the area of the director circle. This is the outline of the problem. Okay. Now this is the center C. Given foci are what? S dash 1, 1 and S is 3, 3. Center of the ellipse is nothing but midpoint of S and S dash, that is 2, 2. Already we discussed it. It is nothing but the center of our director circle. The point of intersection of perpendicular tangents must and should be lies on what? Director circle. So origin is lies on the director circle of the ellipse. So this is one of the point on the director circle. You know the center of the director circle, that is C 2, 2. Its center is 2, 2. It is coincides with the center of our ellipse. So the radius of the director circle is nothing but OC. The distance from O to C is root of 2 minus 0 whole square plus root of 2 minus 0 whole square. That is root of 4 plus 4, that is root 8. Therefore, R is equals to root 8. Once if you get the value of R, you can write the area of the circle or not. area of the circle is equals to pi r square. R square is nothing but 8. Therefore, the answer is 8 pi. Only the logic behind the problem is you have to identify that origin is on the director circle. That is the first concept. The second concept is the center of the ellipse and the center of the director circle are coincident. Both are same. That is, the center of ellipse is equal to the center of the director circle. Once if you know the center and point on a circle, immediately we can write the radius. From the radius, you can easily write the area of the circle. Area of circle is obtained by pi r square. For this problem, your area is 8 pi. Let us see one more problem related to the same concept. See this one. This is the question. The number of points on the ellipse x square by 50 plus y square by 20 is equal to 1, from which perpendicular tangents drawn to the ellipse x square by 16 plus y square by 9 is equals to 1. Two ellipses are given to you. This is one of the ellipse. This is the second ellipse. See the question. You have to find out the number of points on this ellipse. You have to find out the number of points on this ellipse from which perpendicular tangents are drawn to the ellipse. So we have to find out the points on the ellipse. That means some point is on this ellipse. If you draw two tangents that from that point to this ellipse, they are perpendicular to each other. Such type of points are how many? That is my question. What is the outline of this problem? Perpendicular tangents, pair of perpendicular tangents always intersect on what? Director circle. Always intersect on the director circle. So can you find the director circle of this ellipse or not? You can easily find the director circle. So our required points must and should be satisfies two equations. First equation is director circle and second equation is what? X square by 50 plus y square by 20 is equal to 1. So our points must and should be satisfies both equations. If you see how many points satisfies both the equations, then your problem is over. So that is the outline of the problem. So central idea of the problem is perpendicular tangents intersect on the directrix of the ellipse. That is your central idea of this problem. So we know that perpendicular tangents of the ellipse intersect on the director circle. This is the central idea. So what is the equation of the director circle? X square plus y square is equals to a square plus b square. That is 16 plus 9, 25. So what is its radius now? R is equals to 5. Keep one side. This is my x-axis, y-axis. This is the given ellipse. X square by 16 plus y square by 9 is equals to 1. This is the ellipse equation represented by x square by 16 plus y square by 9 is equals to 1. Now, this is its corresponding director circle. X square plus y square is equals to 25. Your points, your required points must and should be lies on this equation. At the same time, they are asking the points which are on the x square by 50 plus y square by 20 is equals to 1. Am I correct or not? This is the given equation of ellipse. Say 2, equation number 2. That is x square by 50 plus y square by 20 is equals to 1. What is a square value? 50. What is b square value? 20. Can you find ab values or not? A is equals to 5 root 2. B is equals to 2 root 2. Observe these values. This is a. This is b. What is r? 5. My question is it b less than or less than a or not? B is 2 root 2, which is less than 5, which is less than 5 root 2. So, our circle x square plus y square equal to 25, radius having radius 5 units, which is more than B and which is less than A, which is less than semi-major axis A and more than semi-minor axis B. This is R, 5. So, 2 root 2 less than 5 root 2. That means the circle and ellipse intersect at 4 real and distinct points. Intersect at 4 real and distinct points. That means you have 4 points on your given ellipse satisfies given condition such a way that the number of tangents drawn from that point to the ellipse are perpendicular to each other. So B less than or less than A we obtained. That means 1 and 2 intersect at 4 real and distinct points. See, this is the ellipse x square by 50 plus y square by 20 is equals to 1. It intersects our director circle at 4 points as shown in the figure. First, second, third, fourth points. These are my 4 points. So, the number of points on the ellipse at which perpendicular tangents are drawn to this given ellipse is 4. So, your point must and should be lies on the given curve. At the same time, your point must and should be satisfies the director circle by definition itself. So, your required points satisfies 2 equations. The type of points are 4 as shown in the figure, because B less than or less than A. This is the very, very important concept. B less than or less than A. So, hence 4 points on the ellipse x square by 50 plus y square by 20 is equals to 1 satisfies the given condition. The entire central idea of the problem is your points satisfies the given curve. At the same time, your points satisfies the director circle of the given main ellipse. X square by 16 plus y square by 9 is equals to 1. By observation, radius is in between the semi-minor axis and semi-major axis. Then the circle intersects the ellipse at 4 distinct points. That is why the number of required points on your given ellipse x square by 50 plus y square by 20 is equals to 1 is 4. Okay, thank you.